All right, we got 10-4, and our 10-4 is our last new piece of material before our 10-1, 10-4 test, or I'll say quest, because it's only half a test of chapter 10. Now, here's the deal. Today's objective, to find the perimeters and areas of similar polygons. It's not going to be a secret. I already got it up there. When we are looking at 10-7, perimeters and areas of similar figures, if the scale factor of two similar figures is A to B, or even the not just the scale factor, but the perimeter ratio, we can pull back and go, hey, the ratio of their perimeters is A to B, and the ratio of their areas is A squared to B squared. Weird, right? Matter of fact, this is so weird that when we get to 11.6, in chapter 11, section 6, we will learn that the volume of a shape is directly related to the corresponding sides being set up perimeter scale factor, because scale factor is the first power. The perimeter area, the area ratio, I should say, is the second power. What do you think the volume ratio would be? Just kind of like if I go from 1 to 2 to 3. Volume is the third power. Okay, volume is cubic. So we're gonna bring this back again. So make sure you gets it, because we're gonna extend the knowledge of it in about a month. Okay. By the way, we have 39 days left as of today. It's not including block scheduled days, which is about 33 days left as of today. So make sure you recognize doing something about your grade starts now, not 7 days out. I always get pissed. What can I do about my grade? Like 18 weeks, just didn't happen. And they're like, well, I can do it all in one. I'm like, dude, if you didn't do it in 17 weeks, it ain't happening in the last week. Make sure you're doing it all the way along. If you haven't been, change now, please. Chapter 8 and Chapter 9 retakes have been available. Okay. If I don't give it to you before break, you won't get it, because when you get back, you should be done. You'll be asking questions, and we should be taking the tests, because 421 is the last time you can retake those. Okay, that's it. I'm not coming back to the third quarter at all. I'm done with third quarter, and so should you be, because you should be getting ready for the final. Okay, so when we get back, it's going to be under 30 days left. So keep that in mind as we're going. We're looking at this. So how do we use it? Corresponding sides, 6 to 9. 6 to 9 reduced 2/3. Are you in agreement? Keep in mind, one of the things that we saw here was the fact that perimeter ratio and side ratio are the same. Perimeter ratio and side ratio are the same. And they also kind of connect to scale factor. Scale factor, perimeter ratio, side ratio, they're going to be the same values. Okay, so what's the ratio of the smaller to the larger? Well, the smaller is 2. I reduced it. The larger is 3. Guess what? 2 to 3. Done. I don't think I have. Oop, I'm sorry. That's area. I was talking about perimeter, 2 to 3. And then my area, I just square those. Always make sure you reduce your perimeter ratio before you go into getting your area ratio, so we don't have to reduce it afterwards. Okay? I like working with small numbers. I like to reduce first. But because of that, once you reduce doesn't mean you found the answer. Once you reduce means you just reduced. So you pay attention to what you're finding and how you're finding it, okay? This isn't significantly difficult. You have to pay attention to what you're doing when you do it. So now, here it is. You're going to do exactly what I just did in problem 2A and B. Go ahead. Pay attention to order. Pay attention to order. I actually tell you what the order should be. Now, here's the deal. The hardest thing of doing these is setting it up and recognizing what you're going to do. I'm talking about a perimeter ratio, so two similar polygons, corresponding sides, and the ratio 5 to 7. Corresponding sides is the same as corresponding perimeters. Okay, side ratio, perimeter ratio, same deal. I got 5 to 7. They want it in larger to smaller, 7 to 5. Okay, because 7 is bigger than 5. That's how I do it. Are you okay with that? We good? corresponding sides. If there's a bigger number, that's the bigger shape. It's going to be this bigger shape. And that's why this corresponding sides was such an important thing to understand when we were doing chapter 7, because we're doing it here too. What's the area, larger to smaller, 7 squared to 5 squared, 49 to 25. I'm done. That's the area ratio. Now remember, we're finding ratios. That means they're going to be setting up proportions. We're going to be setting up proportions to find missing areas. Okay, we're going to be provided a scale factor, perimeter ratio, or side measure, that side ratio, all the same. We're going to use those to get to area ratio, and we're going to solve. And without further ado, let's get it done. When you know the areas of one of two similar polygons, you can use a proportion to find the area of the others. Other, I should say, not others. The area of the smaller regular pentagon is 27.5. That's the area of the small one. What's the best approximation for the area of the large one? 4 to 10. I'm going to try to get that back. I got fat fingers. We got 4 to 10 as we go. And I'm going to set that ratio, but it's reduced 2 to 5. Now remember, this is all set up. I have the scale factor or side ratio, perimeter ratio, and I'm going to make it an area ratio by squaring it. 2 squared to 5 squared. So I've got an area ratio. Okay. Now, I have a proportion I'm setting up. And remember, 2 squared is 4 and 5 squared is 25. They will be that way in a second. I just want to make sure you know where I get that 2 and the 5. Now I got that from side ratio. Now I'm told up here that the smaller regular pentagon is 27.5. Well, that's the smaller, so the smaller should be right there. Hey, look at that, crazy, right? So 27.5 to x, because x is my larger area. At this point, I cross multiply. 4 times x, 25 times 27.5. And I got that. It's all about setup. Once you get the setup, you put the hammer down and you get x. So solve for it. 687.5 divided by 4, I get 171.875. Now, please keep in mind, word problems, word answers, dress up your answer, make sure you don't have naked numbers. Give them units, okay? So we are looking at the area of larger pentagon is 171.88 centimeters squared, okay? Now, I haven't done anything crazy. I went from the perimeter ratio. I took my reduced perimeter ratio, I squared it, had an area ratio. I then took that area ratio and I set up a proportion to find a missing area of one of my shapes. I had to know which one was bigger. Okay, well, it's your turn. Go for it. Number 4. And if you're wondering what a test question looks like, it's 4. Okay. Now, keep in mind, I have the scale factor, which secretly is my perimeter ratio or side ratio. So I've got it done. My area ratio is 9 to 16. Okay, I set up my relationship, and people are like, how did you decide that 96 was on the bottom? Because they said 96 is the area of the larger parallelogram. 16 is the larger value in the ratio. So now, keep that in mind, 9 to 16 is x to 96. X should be the small guy. I cross multiply, and I divide, I get 54. Okay, because I'm dividing by 16. I have to make that square because I'm talking about area. If you forgot about that little step, that's okay. Learn to remember it. Okay, but remember, after you find your answer, dress them up with units. We don't want to have naked numbers out there. So the area of the smaller figure is 54 inches squared. How you doing? Yes, Miss Bloom.
Do we need to set it up every time, or did we just do 9 over 16 times 96?
I would like you to make sure that you do that because I have a lot of people that take that shortcut and they forget which one they're working with. I would just kind of write it down on the side because that's just a little reminder, especially when you come back and recheck your work before you hand in your test. Okay, because it's a real simple one that's to forget about. Because the biggest thing is when I give you the area ratio and you reduce and you forget to take the square root, that's when people will make that mistake. So I would hedge on, oops, be more conservative. So make sure that you put yourself in position for doing the same thing every time. So that way you won't forget, okay? But I get that there'll be shortcuts. Sorry, I got frustrated with something. All right, let's move on. Here's the deal. It's review time. The next 6 to 7 questions is all review of what we just did. Because I need to make sure you gets it because today's review day number 1. Tomorrow's review day number 2, and our test is Friday. Crazy, right? So we're reviewing what we just did. So number 1 and 2, find my perimeter ratio, it reduced, and do the area ratio using the perimeter ratio by squaring it. Go get it. Go, 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 go. Yes, sir. 2 to 9, 4 to 3, 16, perfect. Perfect. Remember, perimeter ratio is set up by corresponding sides. So this first one, you got 4 and 6. Reduce them, 2 and 3. So your perimeter ratio is 2 to 3. Your area ratio is therefore 4 to 9. Yes, sir. They gave it to me. That's all right. It's all right. It's like it's a miracle. Yeah. Okay, so here's the deal. As we go through, maybe if I get this, those are the pieces of information I have there, pieces I have here. How you doing? Are we doing okay? I'm telling you, you got like 6 or 7 of those questions on today's assignment alone. Okay, and they're really great because I'm able to figure out if you gets it or not with the relationship. If you got a question, let's ask. Let's nip it in the bud right now. Doing okay? Reduced perimeter ratio squared is the area ratio. That's all there is to it. Okay? Now, still go on. I already did the work. I did the setup, Miss Bloom. We got it. Area ratio 16 to 9. Get after her. We got it done. Set it up. And some people were wondering where I got values the last problem. Read the question. In number 3. In number 2 above, if the area of the smaller triangle is about 39 feet squared, I was just told the area of the smaller triangle is 39. So I'm going to associate that with my bottom number 9. What is the area of the larger? Well, the larger one is 16, so x to 39 is what I'm looking at to solve for my larger triangle area. Yeah. Shoot. You got that squared. This is 12. Oh, if I flip-flopped it? Yeah, you're fine. You're fine, unless I tell you otherwise. Okay? The question was, would it matter if I, in a previous problem, number 2, if I went 9 to 12 and came up with 3 to 4, and then 9 to 16. And so as long as I don't specify, which one to which, you're golden. You've got 2 choices. Now, after I do this setup, 16 times 39 and 9 times x, I'm on my way to solving my proportion I set up. Okay? And again, after I'm done, the area of the larger triangle is 69.3 feet squared. That's it. Is it making sense? One can only hope, because I'm telling you, I can't even tell you how close number 3 and the previous number 4 is to a test question. The only difference is it's not the test. Okay? Numbers will be changed to protect the answers. That's an answer protection program thing I've got going on. But keep in mind, I'm going to expect the same knowledge. Okay? Now, in number 4, we start recognizing the idea that we are in the understanding of reversing things. What's the reverse of adding something to both sides? Subtracting it. Reverse of multiplying something? Dividing it. The reverse of squaring something is square rooting. So we're going to have a square root in good time, right? A root and toot and square root in good time. So here it is. I'm going to get rid of this for a second. I don't know where that came from. we have a situation where I'm giving you the area of both figures. I want you in the same method. We're going to do the same thing. First thing, area ratio. Well, I know it's 48 to 128. And people are like, why did you include the meters? I want you to know that this is a ratio and the units are knocked out. The units have to be the same. If it was inches squared to feet squared, I have to make the conversions before I can actually do this. Now, 48 to 128. 8 is involved in both. I'm going to reduce. Reduce first. Did you notice we reduced before we squared and we're going to reduce before we square root? Same steps. Reduce. 8 divided by 8, so I got 6 to 16. Now, keep in mind, this is still an area ratio. It just happens to be a reduced area ratio. To get it to perimeter ratio, take the square root of the top and bottom. Square root of 6, square root of 16. And I'm done. That's it. You have to make sure you recognize when given area, reduce the areas because we're reducing the factors that are in common. We've got to take the square root and able to get to the perimeter ratio, which is to the first power. Yeah. Say that again. I'm not simplifying. What? Why don't you like reduce it for like what? Oh, I could have, but 16 was a perfect square and was going to be nice. That's why I didn't. Because 3/8, and it'd still be the square root of 3 over 2 the square root of 2. Okay, and I could have taken out the square root of 2 here if you wanted to. So it would have been the square root of 3 over 2 the square root of 2. I chose to do it a little bit simpler for myself as I went through. I've looked for that perfect square. That's a good question because I forgot to tell you that's what I did in my point. I wanted at least one of them to be a perfect square. Does that help? Okay. Now, if you did it down to the square root of 3 over 2 to the square root of 2, is that horrible? No, it's still a ratio, and we got it made. I just wanted to make sure I had one of them be that whole number. Any others? Doing okay? You ready? Skip 5. And number 6, you must make a change. Somebody hit Shift 5 key and came up with %0 instead of 50. Sorry about that. That was my issue. So now let's go back and check out the problem. The scale factor of the dimension of two similar pieces of window glass is 3 to 5. The smaller piece costs $2.50. How much would the larger piece cost? Larger piece of glass would cost. Now remember, glass is area, but they gave us a perimeter ratio, 3 to 5, dimensions 3 to 5. So I go 3 squared to 5 squared. The cost of the smaller one was provided, so we put the smaller cost on top. And that's an area cost. Cost is area. At this point, after my setup, I have a proportion to solve. Go for it. Yeah. Because you're buying this area of material. You got to look at it that way if it helps. Okay, especially if I'm going to, why does cost mean areas? If I'm going to look at tripling the size of the pane, okay, well, it's not a triple the size of the cost. It's actually 9 times this cost because it's an area I'm working with. It could happen. It could happen. It'd be pretty realistic. I haven't read through the final version of the test yet, so I couldn't tell you. Okay, so now keep in mind as we're going through this, 9 to 25, now I cross multiply, and I find that my cost is $6.94. Now, keep in mind, I used a simplistic value for the pane of glass. $2.50 pane of glass is pretty darn small, okay? If I'm going to be making it bigger, 3 to 5, finding that other area. Okay, so again, as I finish, the larger piece should cost $6.94, and I'm golden. Now it's time. I have a self-quiz, kind of. Problem 7, problem 8. Your turn, go for it. Your turn, go for it. Just like any good restaurant trivia game, I'll start doing mine in about a minute and a half. Remember, this is a practice. Make sure you're getting it done. Make sure you're getting it done. Just don't be waiting for me. If you need to, do it in pencil so you can commit to an answer. And after you get one, do the next one. See how good you can be. Area ratio is 50 to 98. Okay, I put that on there because if I set up a ratio and I forget, I could get confused on which direction I'm going. I reduce because that's been my practice. Hey, 25 and 49, they're actually perfect squares. So now for my perimeter ratio, I take their square root and I get 5 to 7. And I can write it this way. But now I want you to make sure you realize scale factor and perimeter ratio are the same deal. So once you get 5 to 7, I don't have to do it twice. It's 5 to 7 and 5 to 7. But if I have two blanks on a test or a quiz, put them both in. Even if it's the same value, 5 to 7, 5 to 7. Okay? Any questions on that? It's your turn, do 8. Now in problem 8, you may want to use your calculator's function for fractions. In a graphing calculator, the 3 rows down on the left side is your math key. If you enter in 1,875 divided by 135, go 3 rows down to your math key, select 1, hit enter, and enter again, it'll save it as a fraction, 1,875 over 135. For those folks who don't have a graphing calculator, you'll need to use your D to F or F to D, which is decimal to fraction button, and the appropriate fraction button, because one will be mixed numbers and one will be improper fractions, and be able to switch those over if you're not feeling comfortable with your division of reduction when you're dividing out our values for 1875 to 135. That's 125 over 9. No, 125 is a perfect cube. 5 times 5 times 5. Because of that, reducing this next one by taking the square root becomes easier. It's 5 to the square root of 5 over 3. Okay? So keep in mind what I've just found, the ratio of the perimeters in reduced form. Okay? And that's the ticket for today's notes. The assignment today is exceptionally similar. Okay? Have a great day.